Well, good evening and welcome to Kopernik. My name is Drew Desker. I'm the director here at Kopernik, and let's see here. There we go. There we go. Thanks. It's great to have you all here. I have to say that pretty much everybody here in the room are new to me. So just as a matter of interest, who is up at Kopernik for the first time, or maybe not since your 4th grade field trip? All right, a good portion of you. All right. Well, anyway, are any of you members? Oh, okay, great. We've got a couple members. Well, anyway, what I'll point out is that the people that have a membership actually have a valuable piece of information in that a Kopernik membership not only gets you into Kopernik here, but we belong to what's called the ASTC, Association of Science and Technology Centers. And it's a consortium of over 380 other science centers that actually honor each other's membership. So you come here, with your Kopernik membership, but then you could go to Robertson, you could go to the Museum of Science and Technology up at Syracuse, or down to the Intrepid in New York City, or the Franklin Institute down in Philly, and get in for free. And actually, most people tell us that you go to like the Intrepid or the Franklin Institute just for like for two adults to get in. Is more than the entire cost of a year's membership here at Kopernik. So if you like this kind of place, a Kopernik membership might be in your future. So we are actually celebrating our 50th anniversary this year. Back in 1973, we started construction on the facility, and here we are, 50 years. We actually opened in June of 1974, and this year we're celebrating 50 years. In fact, actually next Saturday we are holding a 50th anniversary gala down at the Doubletree Hotel. Actually tonight is the last night to actually register for tickets. So if those are watching on the live stream or those here have any interest in that, you definitely want to sign up tonight so that you can plug into this stellar event. The event itself, actually, if you go to our website here, you can learn. It'll tell you a little bit about what's going on. So it'll talk about. You can learn a bit about the history of Kopernik. You can actually buy your tickets online here, and actually, here's the gala itself. And so it'll start at 5:30 down at the DoubleTree, and we'll have. Sort of a reception area for an hour or so where we'll have displays of some of the Kopernik's timeline and Kopernik's history, talking about the programs that we offer. We'll also have a couple of the groups that are sort of resident here, the Kopernik Astronomical Society, the Gemini Girl Scout Astronomy Club, the Ham Radio Club, that all basically operate out of this facility. We'll all have displays. We'll have a great dinner at the DoubleTree, and then our keynote speaker is Nobel Prize-winning chemist, Dr. Stanley Whittingham, who he invented, if you don't know, the lithium-ion battery and got the Nobel Prize for that back in 2019. So he'll be our keynote speaker. So anyway, I'll go back to our website here. We always have information on what's going on. So tonight's program is going to be on fall skies, but you can also go here to classes and programs, the public programs, upcoming Friday night programs, and you can see things that we have been doing. The International Observe the Moon Night. There was a talk here on ham radio, why it's still relevant, and what's in it for you. Tonight's Fall Skies presentation. Next Friday, the sort of gala eve, if you will, is actually the beginning of World Space Week. And so we're actually going to be, there'll be a presentation on sort of vital signs of planet Earth, how climate change is affecting Earth and space for that matter. And then the following week is our big Astro Fest weekend. It's a 2-day astronomy festival here. So anyway, so things to check out on our website. We do more than just Friday nights here, and I'll loop back to Friday nights. We have a very extensive summer camp program that we offer students from rising second graders through high school. We do a lot of school outreach programs. But I particularly love these Friday night programs because it's actually an opportunity to sort of promote this lifelong learning, especially when we've got younger students in the audience. I say, you know, school doesn't end at 12th grade or when you graduate from college. It's a lifelong activity you should be pursuing. And we're not here necessarily to turn you into an astronomer or a chemist or everything, but being an informed citizen is not a bad thing to do either. But anyway, tonight we are very fortunate to have Art Cacciola from the Kopernik Astronomical Society, the astronomy club that operates out of here, and talk to you about what's going to be available, what you'll be able to see in the night sky, and how to see it. So, Art, if you want to take it from here, you want to turn your mic on and two buttons. Yep, there you go. And let's get your presentation up, and also want to welcome those watching on the live stream. Yep. Actually, you see, there you go. All right.
Okay.
Have fun.
All right, thank you.
It's all yours.
Good evening, everyone.
Hold on. Right on.
Okay. So tonight we're going to talk about a very simple topic. It's very general. It's going to jump all over, but I'm going to try to inform you to make you able to do this, okay? So what can we see this fall? The moon is always something great as a target because it's available almost every day, okay? And there are planets, and right now all the planets are visible, all the 8 planets. Saturn and Jupiter and Mars and Venus you could see pretty much naked eye, although you get a better view with the telescope. There'll be a comet and an asteroid both very, very soon in the next couple of weeks. This is the beginning of October. The fall constellations, and if you're like me and you stay up literally all night till dawn, you'll see the winter constellations coming up. It's kind of cool. Get a preview of the next season. We can see naked eye, from here we can see the Milky Way. How many of you have seen the Milky Way? Okay, very good. A lot of people, I forget what the percentage is, like 70% of the people have never seen the Milky Way. But from places like here where we have, preserved the dark skies, you can see it. And that's a good thing. From here we can see it, and we'll talk a little bit about that. We could, with our eyes, most of us can see stars down to a 7th magnitude or so if it's dark and the moon isn't out. Of course, there are galaxies, star clusters, and nebula. And some of these are actually visible to the naked eye, and some of them will require an aid of like binoculars or a small telescope. And then there are other things like the Preshow Space Station, which is going over right now. However, it's all cloudy. So I'm not going to stop and send you out to look up and say, I don't see anything.
Put the transmitter in your pocket because I think it's...
Okay.
I think because we're getting a bit of scratchiness from that there. I think that'll help.
Okay, sorry. Aurora. Sun is becoming very active again, so aurora is being more and more typical. I looked for the aurora last night, and it was cloudy at my house, as it probably was at yours, but I'm certain I could see the reddish color. It said it wasn't there, but to my eyes I could see it. And then the sun, but I have to caution you with the sun, only look at it with special filters and stuff. All right, so the first tool I want to talk to you about is this thing here called the planisphere. This is a very small, simple one. They come bigger in all different sizes. Some of them glow in the dark. They're really cool. The good thing about this, it's good every day of the year, every year, okay? It never goes out of style, okay? Not in your lifetime anyway. How do you use it? Very simply, you line up the date with the time. So it's September 27th, and it's about 8 o'clock, so I put it like that, and then I just hold it up like this, and I can see what's in the sky right now tonight. And then as it go like into summer, you see the sky changes, okay, in what you would see. There's certain things you see all the time, and certain things you only see a little bit. So this is a good investment, okay? But it's not good for the moon or the planets or comets or asteroids and things, because it's the same every year. It doesn't have the other thing. Mark, would you mind helping me here now? So we have these things called star maps. They're available for free. You can download one every month for free. I have a license with them. I requested it and explained everything, and I have a license for I think it's $200 a month that I could do. So, but everyone can get one of these for free, and probably no one would know if you copied off too, but that's pretty cool to use it. So, what's that? Still hearing scratchiness.
Yeah, I may switch you to this mic here.
Okay.
It's a handheld, but at least it should be hopefully less scratchy. We just need to.
Okay. Thank you. Okay, so the first thing is the map in the front has all the different dates. For example, the equinox was on September 22nd. It tells you the time and when the moon's near Jupiter and all the different things. There's also a map, a star map of that time. And it says it's good for early September at 9 p.m. or late September at 8 p.m. So it's good like that. And on the back, I find it very useful because it has objects you could see easily, just naked eye, then objects you could see with with binoculars or a small telescope, and objects you need to see in a telescope. And when I go observing, I actually take this list with me, and I go through everything. It's kind of cool to just go through it like that. And how do you use this? Well, you see there's a north and a south, and then to the right, it's west. Wait a minute, north, south, what should that be? If that's north and that's south, what should that be? East. That's why they're free. The reason it's like that is because they're designed not to look at the map like this, but to look at the map overhead. So if north is there, I point north up there, and now I see north, south, east, and west are now correct. Okay? So pick one of these up. Just print one off every month. So there are lots of other things. We'll talk a little bit about stellarium in a few minutes. There are many, many apps for your phone or tablet, and even on your computer. Some of them are free. Most of them are free. Some of them you have to pay a small fee for. One that I like is Sky Safari. The basic one used to be, I think, $1.99. Now it's up to $5. But if you spend $10 more, instead of getting 120,000 stars, now you can get 2.5 million stars. Well, okay, you might not want to spend the extra money. Or if you want to spend an extra $10 beyond that, you can get 100 million stars. Okay, there really isn't much value, I don't think, for most of us. The thing I like is these two, because I could use it to run my telescope. The app can run my telescope, so that's a great advantage there. And they're on sale they're happening on sale right now. There are also charts, of course, and books, and magazines like Astronomy and Sky and Telescope, and Practical Astronomer, and Digital Astronomer, a whole bunch of stuff. So this is a program that I really, really endorse. It's called Stellarium. It's a free open source program. It's free. All you have to do is download it. Go to stellarium.org, not stellarium.gov, or not stellarium. stellarium.org. And you could download it in 3 formats, in Linux, Mac OS, or in Windows, okay? When I first got this, I lived in a rural area. I had dial-up, okay? It took 25 or 26 hours. I started it on a Sunday, let it run all day till Monday sometime, and but it was worth it. I tied up my phone all that time. But I didn't get any spam calls. That was a good thing. Today, you could download it in just a couple of minutes with the high-speed connections we have. But I'd really recommend it. It's a program like a planetarium program. And I go, okay, so this is the opening screen. I'm going to escape this for a minute. Come down here. This is the icon for it. You could get this, by the way. There's a mobile version of it for your app. It's also for your phone. It's also free. So it starts out here. It knows I already put in the date. No, sorry, my location, and it knows the date and time. Let me turn off some lights back here. Thank you. So right now, it's showing, if I move the mouse down here, it's showing that it's 8:17 on September 27th, 2024. And this is what I'd see if I'm looking south. You'd see the Milky Way. And it has different features. I could turn on the constellations. I could turn on their names. If I wanted to work, and I don't like this feature, but kids often like it, you could turn on the pictures so they get an idea. To me, it's just distracting, but I'm not a kid anymore, unfortunately. And there are a lot of other things you can do. You could turn on the deep space nebula and galaxies and things. You could turn on and off the planets. There are a whole bunch of features. And when I was preparing for this, I went to the clock here on the date, and I changed the date to this date and time. Actually, I was going by 8:15, so a pretty good guess. So you can go forward or back in time with this thing here just by clicking this. If I want to go forward till December, I could do it like that. Okay. I'm not going to get into a lot of features on this, but I just wanted to show it to you. So this is the opening screen. It points south. You could put in your own scenery if you like. I don't bother, but I do have astronomers that they show where their shed is and where their garage is and where their observatory is. But to me, I just go by the compass points. All right, so today we have what they call a waning crescent moon. What does that mean? Waning means that it's getting smaller. It's getting waxing means it's getting brighter. Waning means it's getting darker. So we went from a full moon, which was the equinox, and now we're going down towards new moon, which will be next week, I think, the 4th or something like that. The moon rose this morning at 3:15. Well, around then, and tomorrow it's going to rise at 3:15 and be visible till about 4:15. So you'll see it in the daytime. I saw it the other day in the daytime, so look for it. The picture on the left is from Stellarium. The picture on the right is from Hubble. I tried to use pictures tonight from the KAS, my friends and colleagues in our club that took these images. They're not always the best that you can get, although some of the ones we've done at Kopernik are among the best. This is an image taken by one of our club members of obviously the moon. So this again was taken by one of our club members. This is the Milky Way, and when you go to a dark sky, you can see it right from the south in Sagittarius, all the way up and across the sky into the north, into Cacciola and stuff. All right, so the planets that we can see today, Venus. Again, Venus set around 5:15 already, but tomorrow it will rise at 10 o'clock.
in the morning, but you won't see it too well in the daytime because it's so close to the sun. But if you wait till around 5 o'clock, when the sun just sets, you'll see that very, very bright star-looking object. That's Venus, okay? That's where we get all the calls. I think I see a UFO. Okay, no, it's Venus. Saturn, so again, stellarium is showing right now, if I looked in a telescope, what Saturn would look like and the position of its moons, okay? And again, this on the right is a Hubble image. The rings, as you can see, are closing up. I think it's a 9-year cycle where they go from one end open to closed and open the other way. So when they're open like this, they're brighter. You can see it better. In about 9 months or so, they're going to be edge on, and for a day or so, you really won't be able to see the rings at all. You need a pretty good telescope to see where the ring is. And then it'll start tipping the other way. And it's pretty neat that it does that. I thought I was going to say something else about Saturn, but I don't remember. Jupiter, again, that's the Hubble image on the left with the great red spot. By the way, Galileo, in his little tiny 2-inch telescope, was the first person to see the moon with the craters and the mountains. He's the first one to see sunspots. He was the first person to see what he thought were ears on Saturn. He said, I know they're not ears, but that's what it looks like. He saw some of the rings, but he didn't understand what it was. And he saw the 4 moons. We call them the Galilean moons, Io, Europa, Ganymede, and Callisto. And that's the position they are right now. If you looked in the telescope, you'd see that. Now, he also saw that great red spot, which has been there for over 400 years. It does change a little bit in color and size and stuff, but it's still there. And scientists from NASA think it's like a giant storm on Jupiter. But it's been raging for 400 years. And by the way, if it's over here on the edge, if you wait 9 hours, it'll come around and be there again. So you could pretty much see it if you look long enough in an evening every day. All right, this is Mars. Again, on the left is stellarium. Right now, you can see the polar ice cap. You can see one of the 2 moons, Phobos. The picture on the right is an image from Hubble. Okay. Talk about a website. This is a website I like for a long time. This was when I opened up my computer, this was my home screen. And it's called spaceweather.com. It has a lot of nice features. This is from today. I updated it this morning. So that's it right now. If you go different things, you could go down. Talks about the comet that we'll talk about. Sunspots, you could actually click on that and see the larger version of the sun with the actual sunspots all numbered for you. It has all the different stories every week. It has different features. But up on top, it has some other stuff like aurora alerts and flybys, which I'll talk to in a minute. So we'll just limit that for now. Okay. So this is the sun. The image on the left is from that spaceweather.com with the sunspots numbered. We're actually in a great time to be looking at the sun because we're approaching solar maximum. So the sun has a cycle of about 11 years where it goes from very dim to very bright with lots of activity and lots of sunspots and lots of aurora. This is a picture taken of the sun in what we call hydrogen alpha. This is what we call a white light filter. It's safe to view, but you don't see all the features. You see mainly sunspots with the umbra and the penumbra will kind of look like a fried egg. But in H alpha, you can see the sunspots. They're up there. I guess if I use the mouse, more people could probably see where I'm pointing. You can see the sun. Oops. You can see the sunspots. Oh, you can't. Oh, yeah, you can. Okay, right there and there. You see things here. These are called prominences. They're actually like a sunspot on the edge, and they're ejecting stuff. And this may be, I'm not sure. This may be a flare, or it might just be a prominence. And it has fracula, a whole bunch of features. It's kind of cool.
I think I may have addressed the mic issue, so let me try getting this on you again, and this way you can walk unencumbered.
It's too loud. Okay. Thank you. So right now we're at solar maximum. We're in solar cycle 25. When I started doing stuff here at Kopernik, it was actually 1989 with solar cycle 22. So I've been around a while, but it's I learned a lot about. It's okay.
So again, there's the website for it. But if you want to get to that website, you could just link to it from the Kopernik site. But it has information about aurora. It tells you the different numbers and things. Here is tonight's forecast. The aurora is going to be way up in Canada. Tomorrow, it's going to come down lower, but still not, here we are in New York, right down here. So it's not going to come low enough. It shows the average for the next 3 days and what you might expect. You want these to be red, up around the 6, 7 number. So this is what it means if you I get text, not text, you could get them text, but I get email alerts from one of the universities about the aurora when they're coming on. An aurora 3 is nothing. If you go up to Alaska, you're good. Okay, but here, nothing. Aurora 5, KP number of 5, is an average number. And we often have, when I get my alerts, they're often 5 or just below 5, around there. 7 is when you really get good nights. And 9, of course, is really excellent. And I've only seen that here about 3 or 4 times in my whole life. But I have seen it. This is actually from Jenny. She's one of the people who work here. And these are images she took back in August 12th. This was actually at 3:35 in the morning. But these are images she took right here at the observatory of the aurora. And actually she caught the meteor shower too in a couple of these images as well. I tried seeing it. Both Keith and I were up in Maine that weekend, and we thought, oh, we're up further north, but we had rain, so we didn't see anything. Okay, so there's a comet. It's Comet 2023. C stands for Comet. 2023 is the year they found it. A3 tells you that it's an Atlas 3, and it's one that's going to be coming in the morning. It's just visible now. So this is actually this morning. It's very low, only about 4 degrees in the east-southeast. It'll be there for a couple of days, then it's going to go behind the sun. But then when it comes back in October, on October 15th, it's going to get higher, and you'll be able to see it. So if you want to get up tomorrow morning, if it's clear, about a half hour, 45 minutes before sunrise, check it out. This is the prediction for later on in October, when it's going to peak. And there are 2 different schools here. One school says it's going to get dimmer and dimmer as it gets later and later, and another guy says, no, it's going to get brighter and brighter. Comets, you never know. You never even know if it's going to come around the sun, if it's still going to be there. So But we have had some good luck over the years with comets, so this is our next hopeful one. It's right here. It's like literally tomorrow and into the middle of October. This is a comet. Another colleague sent. It's from Comet Hyakutake. So this is this was the first comet that I ever imaged. So I'm going back to days of film. I had to go out, set up my tripod, find the comet, take a series of pictures, write down the exposures I used and all that stuff, and then run to get it processed the next day, and then look at the results, and then try again the next night, okay? And after a while, you figured out what you needed. But today with digital cameras, it's so simple. You could say I need more exposure, and right away, you got it. But in the days of film, it was tough. So Kopernik, in the days of film and the earlier days of the internet, was the #1 site on the internet for getting astronomical images, because we share them. We still do. Any image that George or I or any of us take, we put on the site. You could get to it. You could copy it. You could use it. You could do everything, including publish it. But you have to cite it that it came from Kopernik. Okay, but some two really famous images from Kopernik are of Andromeda and of Hale-Bopp. Okay, and that's in the day of film. Okay, today with computers and modern processing and digital cameras and it's much easier. So we're not #1 anymore, but we're still doing a good job. So this is Hyakutake. There's another shot of Hyakutake. This is March of '96. It was near the Big Dipper in the north. This is Hale-Bopp. This is the one I really perfected. Hyakutake was only there for a couple of days. Hale-Bopp stayed around for seems like a month or more. And my son, who was like 2 years old, saw it, and it was like really cool. At '77, so he was 3 years old. Okay, no. 97. Is that the right year? It's supposed to be 97. Yeah, 97. I mistyped on the thing. I'm saying my son wasn't born in '77. Okay. But this is one of the images of the comet. And this is a more modern one. This is from last year in February. This is Comet Neowise, which was easy to see. It was low on the horizon, but you can see it. And again, with modern cameras and modern equipment, you get a much better image, much more easily. So, another thing that's around right now is an asteroid. They're calling a temporary mini-moon. What are they talking about? Well, one of the asteroids is coming close enough to the sun that it's getting pulled into our solar system, and for about 56.5 days or something like that, it's going to orbit between Earth and Mercury, and it's going to orbit around. So it's called 2024 PT5, okay? And it's going to be there 56.6 days. And if you could do some research on it if you like. But that's where it's going to be. It's going to be in the orbit. And then after that, it's going to get pulled out and from our orbit and go back into its big orbit around the sun. All right, so heavens above. So I go to heavens above by... I usually go to space weather, and I go to flybys, and then from there I click on ISS, and it sends me to heavens above, or I click on flybys. So let me do that for you. Oh, hold on. Sorry. All right. So here's heavens above. And I clicked on ISS, visible paths, and again, this was just done tonight. September 26th today, it was very bright, -3.6, so it's brighter than Venus. And it started at 8:12, This is set up. When you get on this website, you put in your location. You can put in latitude, longitude. You can just let the computer tell it where it is. You could put in, Kopernik. A lot of ways you could tell it where you are. But for right here at 8:12, it started at 10 degrees in the northwest, and then by 8:15, it was in the northeast, and it was up at 57 degrees, so it was about that high. And it was very bright, and it went down at 8:16, 36, and went down to 43 degrees. So it starts out dim, gets very bright, and then it fades out. So it's getting the reflection of the sun. And if you haven't seen the ISS, it goes over every 90 minutes, but not over the same spot. So you'll have different flights. So you'll see that there's another flight tomorrow at 7:24, and then 7:27, and it'll be a -3. On the 28th, there's a second one at 9 o'clock, and it's not going to be as bright. But then on the next day, there's another bright one, and then on the 30th, an even brighter one. And on the 30th, the second one I wouldn't even bother to look at. But it gives you that. Okay, what am I doing? All right, so I just went to Heavens Above, then I clicked on ISS. You could get on the Chinese satellite, or you could do any of the things you want that has a whole plethora of objects. All right, and I already showed you that. So another really cool thing is called the Clear Sky Chart, okay? And it gives a prediction of the cloud cover and weather and stuff for astronomy. It's usually pretty accurate. It goes out usually 2 or 3 days ahead, but it updates once or twice a day. So tonight you can see we really want to be in this like dark blues and stuff, but we're in the whites. We did have a little bit of ability to see earlier today, but now it's pretty much all cloudy, and it gives the percentage of clouds and all that. But you can link to that from the Kopernik website. On the very bottom of the web page, there's a link to that. All right, so talking a little bit about constellations. So Ursa Major and Ursa Minor, that we know as the Big Dipper and the Little Dipper. Believe it or not, worldwide, they're the most recognized constellation. And I just read an article recently, either in Astronomy or Sky and Telescope or one of those magazines, that was talking about how the story is so. Oh wait, that's not that's the one of the Pleiades. Never mind, different story. Anyway, so to find the Little Dipper, the Big Dipper, and it has the handle and it has the bowl. If you take the 2 front stars of the bowl and project it out, it comes to Polaris, the North Star, which is the tail of the Little Dipper, the Little Bear. And in between here, by the way, is Draco the Dragon. It goes way up. So the thing about Polaris that's unique is it's always in the same place. So if you find Polaris tonight, you look out tomorrow or tomorrow morning or a year from today or any time of day or night, you look in that same spot, Polaris is right there. Everything revolves around Polaris. Why? Because right now, the tip of the Earth, the axis is pointed pretty much right at Polaris. And as the Earth rotates around, that point stays pretty much the same. It does have a slight deviation, but not very much. Polaris, of course, so when they're out on ships, they didn't have ways to navigate. They'd look for north, and they'd find the North Star, and they can navigate. They know that was north. When the slaves went to freedom in the north, they didn't have GPS, and they didn't have compasses. They just looked for the North Star, and they knew if they headed in that direction, they're heading up north to freedom. So it's played an important role. Polaris is a double star, by the way, and as is right here in the bend of the handle, Alcor and Mizar, and we'll talk about that in a minute. So yeah, here it is right here, Ursa Major. So there are two stars in the handle, and I don't know if you could see it, but up here there's one star and there's another little star right near it. This was used actually as an eye test for both the Native Americans and also the Roman soldiers and stuff. They used it to see if their warriors had good acuity. And if they could split the two stars, they said, okay, you have good eyesight, okay? Because they didn't have optometrists and things like that in those days. So there's Mizar and Alcor. In that area, too, there's M55, the Whirlpool Galaxy, which are actually two galaxies that are joining together. One galaxy's kind of cannibalizing the other, but they're join. That's the future of galaxies, is they get bigger and bigger, and they just eventually be all super galaxies. And there's a globular cluster there too, M3. M stands, by the way, for Messier. Messier was a French comet hunter, and he was looking for comets. And whenever he found his fuzzy object or his bright object and said, it's a comet, and then he did more studies, said, no, it's not a comet. So he marked it like a landmine. Don't go there again. Don't go there again. And today he has like all these objects that are like really cool, and they call them the Messier. But he did that in the 1700s. So a globular cluster. So a star like our sun is probably third or fourth generation. That means it formed, and then it went into a nova, or expanded, lost all its gases, and then formed again, combustion again. And it did that 3 or 4 times. These stars are original stars. They're almost pure hydrogen and helium, and they're from the beginning of the universe. Same stars that, ours is only 4.5 billion years old. These are almost as old as the universe. Sagittarius is one of my favorite constellations in the summer. It's in the south. If you look out tonight, it'd be, where am I? Right down there. It'd be low, and you'd see Sagittarius. I often tell my scouts and kids that this is like a teapot. There's the spout, and there's the lid, and there's the handle, okay? And right out of the teapot is where the Milky Way seems to start. It looks like steam coming out of the kettle. But it's really not that, Sagittarius. I'll lose my mouse. But in there's Lagoon Nebula. There's M25, an open cluster. What's an open cluster? It's a bunch of stars together that aren't really close. Like this is M22 is a globular cluster. They're all held together by gravity. Open clusters are open. They're pretty and they're bright and they're young. M20 is the Trifid Nebula. M17 is the Omega Nebula. There's a whole bunch of, all these things here are all deep sky nebula things in that area. So in Cygnus the Swan, another nice thing. So you have the tail of the swan, Deneb, and then there's the head, Albireo. And you can see the wings out here and out here. Sometimes they call this the Northern Cross, by the way. But Albireo is a double star, and it's really beautiful to look at in a telescope. It's a beautiful blue and a beautiful golden color, yellow. And this doesn't give it justice. This is an open cluster here. Again, young, bright stars that are kind of they're associated. This is the Veil Nebula. It's a remnant of a supernova. So what's a supernova? All right, so let me go back to our sun. Our sun is an average-sized star. Our sun is right now it's in equilibrium because the forces of it, burning and stuff is pushing out, and gravity is pulling it in, and they're kind of equal, so it's stable, and that's how come we have life on Earth, okay? Eventually, gravity is going to weaken, and it's going to start expanding, and in about 4.5 billion years, around the same time Andromeda and the Milky Way join together, they predict that the sun is going to get so big it's going to burn up Mercury and get bigger and burn up Venus, then get bigger and burn up the red giant, burn up the Earth, and go all the way out to be a red giant up to the orbit of Mars, okay? And then it's going to kind of collapse on itself and then become a little dwarf brown or white star and leave this beautiful ring of gases. And from the gases, new stars form and planetary material. This is different. This is a supernova. So a supernova is a remnant of a massive star like Betelgeuse, a huge star with like 100 solar masses. And when that does that, it actually explodes. And it explodes violently. And this is the shell of the gas of that. And that object's actually very big. In a telescope, you would look at, you'd have to look at like one part here, like this is called the Veil Nebula, like the Witch's Broom, or look around here, and just move your telescope around to see all this. It's a very big object. So in Lyra, which the HARP, you may not really know it, but there's a bright star in it called Vega. And Vega in the summertime is that bright star that's just pretty much right overhead, okay? Even today, it's pretty much up there. And in Vega, there's the Ring Nebula, which is a planetary nebula. So remember I told you about our sun? This is what's going to happen. It's going to end up as a little white dwarf star right in the middle, and the outer shell and the gases are all going to expand out here. Orion, this is my favorite winter constellation. It has two bright stars, a giant blue star called Rigel, and a giant red star they call Betelgeuse. And scientists they believe that Betelgeuse is going to go supernova soon. It's actually shown some signs already where it's dimmed and gotten brighter again. They say it's going to happen in the average person's lifetime, hopefully. So I'm looking forward to that. Not that I don't like Betelgeuse, but I want to see a supernova. It'll be so bright that you'll see it in the daytime for about a month. You'll see it like you would see Venus and the moon in the daytime sky. You'd see it. It'd be that bright. And in that area right below it. So this is, of course, the three belt stars. So this is the most, it's a very commonly found object in the sky because of the three stars in the belt. And down below the belt, there's an area called the sword. Okay, so this is the shield, this is his shoulder, this is the club. But the sword, here, there's a whole bunch of nebula, one of which is the Orion Nebula, which again is naked eye. From a dark side, like Kopernik on a dark night, you can look up there and you can see it glowing. You can literally see it glowing. You put it in a telescope or binoculars, you can really see it even better. Then there's the Horsehead Nebula, and the Flame Nebula is right there with it. Again, these images are from KAS guys, okay? Guys from our club that, some of them are better than others, but they're ours. With our Kopernik equipment and our own personal equipment. This is a harder object to see. I've seen it a number of times, but you really want to have a filter and stuff to look at that. Taurus the Bull. So if Orion's over here, he's kind of facing Taurus, and there's the V shape of Taurus, and then there's the Pleiades right here. This is the story I was talking about before, M45, the Pleiades, also known as the Seven Sisters, or even the Subaru. This story, the Seven Sisters, is so consistently across from the bush in Australia to Africa to Europe to Americas, all across the world. There's a similar story about sisters and this constellation. And they figured out the reason, and the reason is because I forget how many, I don't remember if it was 10,000 years ago, they had that story in Africa, and then from there people migrated to all different places around the world, and they brought that same story with them. And it's an interesting article, and it's in last month or this month's issue of one of those astronomy magazines, so look it up online if you're interested. Cassiopeia, this is the W. It's easy to recognize in the northern sky. It has two things in it that are really cool. It has the Heart Emission Nebula and the Soul Emission Nebula. So it's the heart and the soul. These aren't very easy to see with the smaller telescope. These are actually photographs taken again by the KS members. This is Andromeda. Again, this is a naked eye. It's one of the only galaxies we could see naked eye. It's really far away, and we could see it. So if you were here at Kopernik, I tell you, look up there, and Cacciola would be there, and Andromeda would be over here. I said, look right there. You see that little fuzzy thing that keeps popping in your eye? That's Andromeda, okay? And you could see it. This is an edge-on galaxy. So this is more of a face-on galaxy. This is an edge-on galaxy with the disk in the center where it bulges, but it's more of an edge-on view. But this is a telescope view. This is a great glob, Hercules, M13. It's about 500,000 stars, again, all held together by gravity, ancient stars. This is the Helix Planetary Nebula. Again, there's the original star. It's gone down to a little dwarf star. It's left a beautiful shell. A lot of these planetary nebulae are just beautiful objects to look at in telescopes. You won't see them naked eye. This is just an example of one of our members here. He did all this plus some other stuff in one night. Okay? So things are getting easier, and he's good. So we have stars that are circumpolar. So there's Polaris right there. Okay, there's the Big Dipper, followed up to Polaris. All these revolve around this. So in 24 hours, at 8 o'clock tonight, the Big Dipper will be right here. And as the night goes on, it will turn sideways, then upside down, and then sideways the other way. And then by 8 o'clock tomorrow night, it's going to be back over here because it's circumpolar. They all orbit around these things. This is the summer triangle. And believe it or not, even though it's not summer, it's still visible right now. So you can see this Cygnus of Swan we spoke of. And there's Albireo, and there's Deneb. And there's Vega in Lyra. And then the third star is Aquila in the Eagle, right there, Altar. And these three stars, Altar, Vega, and Vega, make up the summer triangle. Not Vega, Deneb. Thank you. And this is another close-up of a similar thing, Cacciola. There's an object in there. So this is just, these next shots are just thrown in there. But right now, at 8 o'clock tonight or a little after, if you're looking south, this is what you would see. And this is near the end of the summer, actually. It's the beginning of the fall. In December, I went to December 21st, which is the winter solstice, okay? And on that day, looking south, this is what you're going to see. Because those other constellations all went south, and ones from the east are migrating to the west. And you'll see here, here's Lepus. So you have Orion the Hunter, and he's with Taurus the Bull, and Orion the Hunter at his feet is Lepus the Rabbit. And that's what that is there. And looking west right now, you have, so here's the Big Dipper again, and there's this is Boötes the herdsman. It kind of looks like a kite. And one way to find it easily is you follow the arc of the Big Dipper. So you arc to Arcturus. So you arc to Arcturus, and that's the bottom of this constellation. It's a bright star. And then actually below it, earlier in the summer, you get Spike down to Spica. So we have little tricks in that. You find Polaris by going up this way. Have all these little tricks to navigate the sky. This is looking west in December. Again, these are constellations for the summer. They're starting to set. There's the Vega. There's Deneb. Okay. This is Delphinius. It's in the just below the Milky Way. It looks like a dolphin. It's kind of cool. But if you look west that was in December. Okay. I already did the other one. Now, if you're looking north, right now, you'd see the Big Dipper and Polaris and things, Cassiopeia. And then in December, you still see a lot of the same things because they're circumpolar. They're always, every day of the year in the northern hemisphere, at our latitude, they'll be visible in the sky. Sometimes Big Dipper is going to be really low, sometimes it'll be really high, but it's always going to be in that circumpolar. Looking east now, these are where things are rising. So over here you have Pegasus, the Great Square. You have some, and then again in December, you'll see we're getting now the Gemini twins, and we're getting, oh, there's the Orion Nebula. You're getting Orion, and over here's Vega, and there's Lepus, the rabbit. And there's Sirius, his honey dog. Sirius is the brightest star in the nighttime sky. And then these are just things you could see in December. Again, Cassiopeia and things. These are up high. So, and that's all. So, at this point, I'll entertain any questions that you might have.
So I'll ask you to use, especially for the people on the live stream, just
Restate.
restate this, the question. Right?
Okay. Does anybody have a question? Yes.
Isn't there a tail of objects in the constellation Celia that one of the objects you can't see?
So I didn't catch the beginning of what you said. You said in the constellation Celia, an object you can't, constellation you can't.
There's a star that orbits another object that can't be seen with a telescope.
Okay. Certainly, there are certainly many objects that you can't see. Some of them are locked, and you never see them because they're always locked in that position. Like the moon. We don't see from the Earth the backside of the moon because it's locked in orbit around the Earth, and we never see that other side. So if that's your question, yes, you're correct. Okay.
Actually, I was going to mention that some people asked about that mini moon and whether we actually can be able to see it. In actuality, it's only about 30 to 40 feet long, and I believe the closest that it gets to the Earth is 1 million miles away. Now, just to give you a sense, the moon is 250,000 miles away, and it's probably about 4,000 miles in diameter, so this thing's pretty small. And even with our biggest telescope, our 20-inch telescope, it's still not sufficiently able to be able to pull that in. So although technically we are getting another moon, you're not going to really be able to do much with that information other than know that it's somewhere out there.
Yeah, when I first heard about that, the headline was, there's going to be a second moon. I'm going, what? I didn't hear about this. But so it is orbiting, technically it's a satellite orbiting the Earth. So it is a moon. But it's really going to, like you said, it's an asteroid, and it's pretty small. Let me go back to that slide to see how bright it's going to get.
While you're doing that, we do have a question from Damien. Says, thanks for the information you presented. May I ask you where you purchased your cool tie?
I usually purchase a tie at NEAF, Northeast Astronomical Forum. I buy them. I was a school teacher, so I'd always buy theme ties, and I have probably 10 different ties that I wear. I have ones with the planets on it and ones with constellations and all different ties, but that's where I got it, at NEAF. I have bought them from vendors at trade shows and things too, at star parties as well. But typically I go to NEAF and there's a guy in the back that sells ties, and every year I go and I buy one or two. Actually, I remember I gifted one to you one year, Drew.
Actually, you've given me two, and I
Okay.
wear them often.
Okay.
Thank you.
Question. The mini moon, that's going to be in orbit around
So for a while, for 56.6 days, it's going to stay in an orbit around the Earth. But eventually, it's going to get pulled stronger by the sun and get pulled out of orbit and go back to its orbit of, I didn't know about this object until like literally a week ago. Let me find it. So NASA scientists, the second moon, that's where it comes from. It's a tiny asteroid, I gave you the name. Mini moon orbiting the planet for about 2 months, starting September 29th and ending on November 25th. So they've been tracking it for 21 days. That tells you where it got the research from. But it's only going to be for 56.6 days. Because the Earth's gravity will pull it into its orbit, and the asteroid will have a negative geocentric energy, meaning that it can't escape the Earth's gravitational pull. It will orbit around Earth in a horseshoe shape before reverting back to the heliocentric around the sun energy, meaning it will rotate around the sun again like the other planets and the NEOs in our galaxy. Okay, so it's not going to stay. Now, if you come to Astrofest, there's a speaker be talking, I think, on Saturday night about Titan and the Earth. And I heard a very interesting theory about the moon. So I've learned over time that they thought that the moon formed from a collision of a larger object, maybe the size of Mars, that collided with the Earth while the Earth and the other planet were still molten. And they hit, and the debris went up into the atmosphere, and it ejected around, and it formed the moon. That's been the highly accepted theory, and one of the reasons for that is a lot of the materials in the moon are the same as on the surface of the Earth. That was original thinking. But now they've done some more further analysis. Again, I got this from a talk in I don't know, September probably. And they're saying that close analysis, they're similar materials, but they're not the same. And they're actually thinking that the Earth, the moon actually was captured, okay? And it's pretty interesting. I'll have to. So it's another new theory, okay? A captured object instead of evolving from that. Okay. Yes.
Assuming it was a tremendous amount of math and making calculations to come to these conclusions, along with gathering a whole lot of information.
That's extremely correct. He's saying, is it correct to assume there's a whole lot of data and gathering of information and technology to make these calculations? And yes, right now they're worried about finding these asteroids that are coming towards us, especially ones that are in the sun, not in the sun, but facing the sun. Because as an astronomer, I might see an asteroid out in the dark spot of space and see it moving because it moves over time. But one in the sun, first place, we don't see in the daytime, and they're worried about some of those because some of them are really big planet killers. But yes, what you're saying is very obvious. Yes, very true. Yes.
Well, I just wanted to say that the idea that the moon was captured is not a new idea.
No.
That's been around for years. That was one of the first beliefs. But the sources that I saw said that it's not likely because it's too close. Its chemical makeup is too close to just have been captured by the Earth.
Okay. But if they formed it around the same time, I don't know. I'm not the scientist who gave the talk. So I was just telling you another theory that I had heard, and you're telling me that the theory is old. And a lot of stuff has been around and comes around again, just like everything else you've ever seen around. So that's good. Okay. Any other questions?
No, I think we've exhausted. Oh, we got one question here in the back.
You talked about Betelgeuse supernovae.
Yes.
Hopefully, I mean, I know I'm see that. That'd be interesting.
Yeah.
What would we see afterwards? How would we go further with that constellation?
So afterwards, you would see it as a ring, and it will get bigger and bigger and bigger of the gases that are, as it expands. That's what the supernova are. So I think it was like 1054, they documented a supernova, and to this day we see it, okay, M1, and the Crab Nebula. And they actually they documented. I think the Arabs and the Chinese both have it in their history about this great explosion in the sky, and it's there. You see M1. It's the Crab Nebula, actually. Is that the Crab Nebula on the? Yeah, the one over there on the board there. Yeah, for a long time. But eventually it will fade and get bigger and bigger and fade, but not in our lifetime. Okay? Okay. Well, thank you very much. You've been very polite.
All right, well, thanks again. Art, I appreciate the time and effort you put into this presentation this evening. Again, did everybody get a star map? All right, great. So we have a rule here that when you come to Kopernik, you can't leave until you actually look through a telescope. However, tonight won't be a particularly fruitful look through a telescope, but we'd be very happy to actually give you a tour of our scopes and show you some of the other images that we've taken here. So if you have a moment, we're happy to take you in there. Also, if you paid to get in, when you don't get to look through a telescope, we actually give you a complimentary card to come back on another night. So make sure you grab one of those on your way out. And especially those that are up here for the first time, when you're driving back, watch out for the deer. I actually drive down the middle of the road. It gives me a couple of extra milliseconds of time to react for that. So, comment or?
So I've been here like twice. In recent times, and both times I saw a deal.
Yeah, I did. Yeah, there's actually a great flock of turkeys, about a dozen turkeys also. That seems to be, although those are more of a daytime kind of phenomenon. But anyway, thank you much for coming. Oh, another option, another.
Just an observation, Drew. Last week, somebody pointed out something to me that I don't know how I'd never noticed it before, but you have signs for representing the distance of the planets from the sun.
Right.
As you go out the driveway, they're mostly on the right side of the road as you're going down the hill, but there are a couple of them that are on the left side of the road. It's kind of fun to, while you're driving slowly, of course, because of the hill and the deer and all that. So if there are two of you in the car, one of you at least be looking for those signs that say the different planet names. It's fascinating. And it goes way on down the hill till you get almost to the bridge at the very bottom where there's the intersection. And Uranus is the last one down.
Actually, that's Neptune.
Is that Neptune?
That's Neptune.
Yeah, I
So
must have missed
that was
Neptune
actually an
last
Eagle Scout
week.
project. And if you recall from your fourth grade science curriculum, Kopernik was actually the scientist that developed what's called the heliocentric model of our solar system. Up until Copernic's time, people thought that the sun and all the planets revolved around the Earth, but sometimes those planets looked like they would be moving backwards, and that bugged Kopernik. Why would a planet be moving around the sun and then go backwards? So he did the math and said, if you put the sun in the center, then it all makes sense. So when you leave Kopernik and take a right, heading down the hill, right at the entrance to the parking lot, that's where you see the sign for the sun. 130 feet away is Mercury. Another 100 feet away is Neptune. 1.8 miles away is I'm sorry, try that again. The sun, 130 feet away is Mercury, 100 feet away is Venus, 1.8 miles away is Neptune. And we don't talk about Pluto. See, my theory about Pluto is if you called it anything else, nobody would care. Because it has the same name as that cute dog, you know, everybody's all up in arms. But Pluto doesn't act like every other planet. And but anyway, so there you go. But anyway,
So I want to just mention that on October 11th and 12th, we're having Astrofest here. Be Friday night. There'll be a couple of speakers. There'll be one at 7, then there'll be the keynote at 8 o'clock. And then on Saturday, all day long, starting at in the morning, they'll have solar outside, and they'll have different talks and workshops up to the speakers in the evening again. And in the evening, by the way, on those weekends, we stay all night if it's clear, and you just observe. Actually, Mark and I are the guys who stay here all night to make sure if something happens, everybody's safe. You're going to help me this year again, aren't you? Yeah. Okay. And if you're interested in joining the KS, it's a great group of people. We have guys and girls. Actually, those two are KS members. Those two are KS members. He's a KS member. Drew, I am. Doc's out here tonight. There are a bunch of us, and a lot of those images. So we meet the first Wednesday of the month here at 7 o'clock. And we also have a Zoom if you're interested in joining. Okay. Well, thank you very much, and have a good evening.
again, so what I'll do, it's 10 after 9, well, it's about 12 after 9, in about 5 minutes. If you want the tour of the scopes, I'll just meet you right outside of the gift shop, and we'll take you in. All right, thanks.